Hello, everyone. Welcome to the Mental Health and Neuroscience Masterclass. We're just going to wait for about a minute while everyone joins the Zoom room. Those of you who've just joined, hello, welcome. We're just waiting for around a minute just so everyone gets into the Zoom room and is ready to go for the webinar. I think that's around a minute, and I think we should start. Welcome again. Hello, everyone. Welcome to the Mental Health and Neuroscience Masterclass. My name's Dan Hermans. I'm Professor of Youth Mental Health and Neurobiology at University of Sunshine Coast Thompson Institute, and I'm the Program Coordinator for the Mental Health and Neuroscience Postgraduate Program. And with me today in the webinar is Dr. Chrissy Driver, who is the Course Coordinator of the MHN program, and you're going to be hearing quite a bit from both of us. I just want to start with some housekeeping. Firstly, to mention that this webinar will be recorded and it will be sent out to all the participants. So thanks for being here. And on that note, we're really blown away with how popular this has been. We've had over 500 registrations for tonight's webinar, and we had a webinar last night as well that was very well attended. So on the topic of the numbers, we might not be able to get through all the questions. So I'm hoping that we can get through many of them. There will be a Q&A session at the end, the last 10 minutes or so. So I urge you to put questions into the chat feature of Zoom. We will be covering issues around eligibility, but if we don't quite get to your question, please put those questions there in the chat. So I'd like to begin by acknowledging the traditional custodians of all the lands upon which we gather today. And on behalf of the UniSC team, I pay my respects to their elders past, present, and emerging. And I extend that respect to Aboriginal and Torres Strait Islander peoples participating in this webinar. So as mentioned, this is the panel for tonight, I guess, for this evening's webinar. Chrissy Driver, Course Coordinator. Chrissy's going to talk about program overview, especially around issues on eligibility and content. And then I'll be doing a masterclass about the neurobiology of adolescent brain development towards the end. So hopefully that'll get us to around 10 minutes or so or 5 minutes or so to 7 a.m. Eastern Standard Time, and we're going to open up for questions. And as we did last night, we're very happy to kick on for another half an hour or so if people are willing and able. So quickly, I just wanted to summarize what we do at the Thompson Institute, University of Sunshine Coast Thompson Institute. It's a mind and neuroscience research center that started in early 2017. And we very much have what we call this CARE model, a clinical advocacy, research, and education components to it. In terms of clinical services, we have psychiatry, psychology, a healthy brain aging clinic, novel techniques or novel interventions, I should say, such as brain stimulation and neurofeedback, as well as clinical trials focusing on novel medications such as ketamine as a treatment for depression and other mental disorders. Advocacy, we certainly host a lot of public and community events, much training. We have a lived experience research program. In terms of research, we do focus on 5 main programs, of course, youth mental health, suicide prevention, aging and dementia, stress-related disorders, and the newly formed program of research starting now in eating disorders. So we're addressing some of Australia's most pressing mental health issues. These research programs are very much supported by what we call platforms. So maybe the next slide will explain more about that, but we have imaging and things like data analytics are running across these platforms. And then, of course, education, perhaps most relevant to tonight's, this evening's webinar. We do, of course, and we're very proud of our mental health and neuroscience program, which is been going for about 2 years, 2.5 years so far. But in addition to that, we also have high degree research students such as PhDs. There's Masters of Psychology students at the Institute as well. And we have other forms of training. But as I mentioned before, just to explain a little bit more about the platforms and the research themes, along the middle here, these are the research programs at the Thompson Institute. And then, of course, running across those, we have clinical trials, molecular biology, neuroimaging is a big focus of what we do as clinical services. So it's also important to note that a lot of this work is very much reflected in the content for the mental health and neuroscience postgraduate program. So I'm just going to start now with a quick video, which is giving you some insight, some views from some of our students. And then shortly after that, you're going to hear from Chrissy about the overview of the program and program content.
The information that I've learned through this course has been applied into my job many times when it comes to the vulnerable populations, those at risk of mental health and suicide. By studying online, I can still get a postgraduate education while working the job that I love.
As an educator, we certainly are tasked with delivering the curriculum, but we're also tasked with ensuring that the young people are safe and supported.
I'm an advanced care paramedic with Queensland Ambulance Service, and I work as a rural reliever across a lot of regions in Darling Downs. I chose to study neuroscience and mental health at USC because they offered an in-depth background into the neurobiology of mental health to better understand why mental health develops and how to better treat the symptoms and conditions my patients have.
I've obviously got a real vested interest in mental health and neuroscience, having done my background in psychology and then continuing to work with young people each and every day. So I've been able to engage with a lot of the learnings in my current context as a secondary school educator, particularly around mental health and mental illness in adolescence. I work full-time at the moment, so obviously online study was my preferred option. In my classroom teacher role, I teach senior psychology, so I've found that being able to engage with the content in this program has enhanced my practice as a classroom teacher and certainly warrants a lot of interest from my students.
So what I really like about being involved in this program is, first of all, it's one of a kind in Australia. It's the only fully online mental health and neuroscience course. The other aspect I really enjoy is actually getting to see the students, even though it's in an online setting, getting to chat to them and hear about how they're already applying their knowledge in their professions and in their practice.
Studying online means that I don't have to go into uni. I can study from home in my own environment, on my own downtime. Each week we get to have Zoom classes and ask real-time questions and get answers from experts in the field.
The great thing about what the students get to experience in terms of the teaching staff is that we have such a wide range of contributors to the content. So the students get to hear from a variety of experts at the Thompson Institute who are all at the forefront and cutting edge of their research areas. So we have a very multidisciplinary cohort: paramedics, nurses, counsellors, social workers. Everybody's recognising that this is a really important aspect of their work.
As educators, we know that the young people in our care are faced with unprecedented amount of challenges, and having the knowledge and developing this literacy around mental health and neuroscience is invaluable for us educators because it helps us to ensure that the students in our care are well supported.
Studying mental health has been really important for me because as a paramedic I can deliver that frontline care to those in crisis, to be able to help those people who are often misunderstood or stigmatised, to break that barrier and deliver the best possible care that I can.
Well, we're very proud of that video. I hope you enjoyed it. And now over to Chrissy.
Thanks,
The
Dan.
information that I've learned.
I'm so proud of it. I'm going to show you it twice. Thanks for the introduction, and yes, very excited to get to tell you all about our courses and just give you a little bit more information and try and cover some of the things that some of the questions that we often get asked. So as you can see in this video, we do have a range of students from different backgrounds and professions that are doing our course. So as well as teachers and paramedics, I'm going to give you an idea of some of the other professions that our students are currently in. So we've got lots of health workers such as speech pathologists, exercise physiologists, dietitians, OTs, mental health clinicians, counsellors, social workers, psychologists, nurses, chiropractors, naturopaths, But we also have students with more science-based backgrounds, so environmental science, biomedical science, high performance sport. But we've also got a lot of people representing more kind of business sectors. So we've got public relations, crisis management, business consultancy, workplace health and safety and wellbeing, policy and government, and lots more. So we do have a really broad range of backgrounds with our students. So what they all have in common really is that there's an evident passion to help those people that they come across in their personal and professional lives who might be struggling with mental health concerns. And so we're seeing that all these people from different professions are recognizing that having this mental health and neuroscience literacy is really important to enhance their current practice or profession. And the topic of mental health is becoming increasingly relevant no matter what field you're in. So, you know, whether you want to expand your career horizons, start a career in emerging research fields, which you'll hear about a little later, or go on to higher degree by research, or just apply mental health support in your current career, this program is definitely applicable to a wide range of multidisciplinary fields. And I just want to point out now, we're very excited to let you know that the course now has Commonwealth supported places, which means that drastically reduces the cost of each of the courses. We know that postgraduate study is expensive, so this is really beneficial and a really great time to get on board because they do have reduced prices. I think there's some information on the website about that. Okay, so I'm just going to go through some of the key points about our programs. So we currently offer a graduate certificate, a graduate diploma, and we'll soon be starting a fabulous master's in mental health and neuroscience. So the grad dip and the grad cert have been approved for these Commonwealth supported places. So that's great, and especially if you're wanting to apply now, it's perfect timing. I will talk you through those different courses in a little while, but I just want to explain how the programs sort of fit together. So they are nested. Now, this means that if you want to start in the grad cert, which is just the 4 courses, this way you can get a taster of the content before committing to the grad dip, then you can do that. And then if you complete the grad cert and you decide you want to carry on, you can upgrade to the grad dip and complete the other 4 courses to get your graduate diploma. Of course, you can apply straight into the grad dip, which is the full 8 courses. So there's a couple of options there. We're starting the Masters next year, which will culminate with a research focus, and this includes a supervised thesis, currently using secondary data, but also conducting data analysis and manuscript writing, which will hopefully end in publication. So the idea of this Masters is really to give you a potential alternative pathway to high degree by research if this is something that you're interested in. So again, you can start in the grad cert and work your way up to the grad dip and then to the Masters, or you can apply straight into the Masters. We're still kind of tweaking the eligibility criteria for the Masters. So watch this space for that. That will be on the website soon, but we will go through the eligibility for the grad cert and grad dip tonight. So the grad cert is currently offered part-time. So that's about 2 courses per semester, 1 or 2 courses. But the grad dip, you are able to do that full-time. So you can do the 4 courses per semester, which means you would get that grad dip done in 1 year. Or you can obviously do that part-time as well. For both courses, you can start with whichever course you prefer. There's no designated order, it's just whatever's available in that semester. And actually you can start in semester 1 or semester 2. On that note, semester 2 starts on the 24th of July and we still have applications open. So if you're wanting to get that last minute application in, then you definitely still have time for semester 2. The Masters will be a little bit different in terms of how you can go through the courses, in that you will need to complete the all 8 of the grad dip courses before you then continue on to those final research focused Masters courses. Now, lucky for you guys tonight, you will also get a little taster module from us. So at the end of this webinar, you get an email with the recording and also a little taster module to give you an idea of the topics that we cover in our grad cert and grad dip courses. Okay, so let's have a chat about eligibility. So you, next slide please, Dan, thanks. So in terms of eligibility, you may actually be very surprised at what degrees we will consider relevant. Of course, there are many relevant undergraduate degrees such as health, science and psychology, and these are helpful in terms of those foundational skills and knowledge, but we do also consider people with degrees in what might seem to be unrelated areas. So far, we've had a number of students without these types of degrees who have been very successful in our course. So yeah, don't worry too much about that. It might be a steeper learning curve if you don't have a solid science, health, or psychology background, but it's not impossible. And as I said before, we've had students from a variety of backgrounds. And in terms of eligibility, we are also interested in finding out if you have any vocational or work experience in mental health, and also why you might want to do this course. Oh, something's happening. Okay, that's all good. So if you don't feel you have the relevant degree, you can also submit a statement to say why you might want to do this course. And if you have got a specific inquiry that is quite individual to your context, then please do use the inquiry form that will be available after this. But what happens if you don't have a science background? So these allied health, psychology, and medical sciences are helpful because at the end of the day, the content is ultimately neuroscience orientated. But we do in the way we teach the content, we do a lot of scaffolding to build that basic brain knowledge early. And the neuroscience components are focused on how they're applied in the mental health context. So we're not expecting all of our students to come away knowing absolutely everything about the brain. And in fact, Dan and I will be the first to tell you that we're still learning new things about the brain all the time. So neuroscience is a massively growing area of research and knowledge at the moment, which is so exciting. And so it's a great time to be involved in a course like this, because with all the imaging techniques that we're able to utilize now, we are learning so much more about the brain. Honestly, some students do find it a little bit tricky to start with because neuroscience is a whole new language, but it will become more normal as you progress through the course, and you will start to notice themes across some of the content, especially in terms of like the different brain region and networks and neurotransmitters and all those sorts of things. You'll start to hear that there are some common themes across disorders particularly. Now, we always get asked about assessments and how that is if you haven't got that science background. So I want to kind of allay some of your fears and say that we're actually looking more at your critical thinking skills, challenging science communication, being able to put forward balanced arguments based on the evidence base, as opposed to just looking for this rote learning, which you might do for exams or just writing standard essays. So we have a lot of variety in our assessments that are looking at those skills as well as some of your knowledge. So essentially, we're trying to give our graduates these foundation skills in how to use your knowledge rather than just learning lots of information that might not have an applied focus. Now, finally, a question we get asked is in terms of career pathways. So at this stage, the course doesn't have accreditation statuses for college or societies, but this is something that we would like to look at in the future. What I can say is that our current students are giving us examples as to how they are using their qualifications to benefit their current careers. So, for example, the assistant principal that was featured in the video that we saw is drawing on his course knowledge to be more across the neuro aspects of his psychology teaching, but he's also using it to enhance his understanding of current mental health issues that are facing the youth in his school. And this is in order to be able to better support his students, but also to equip his teachers to be able to support his students as well. So for others, it's about becoming more specialised in their current practice. So for those health workers that I mentioned, having this mental health and neuroscience knowledge has given them more experience to be able to, recognise early signs of mental health issues in their clients, and then enabling them to better help those with those concerns. So it's all building that better understanding of their clients' needs from a holistic perspective. So others are using their qualifications to go for promotion or advanced careers. Employees are seeing the skills and training that they have in this area and then how that can be applied in their profession. So there's obviously the personal and professional application knowledge, but also our students are using their qualifications to enhance their resumes when applying for more senior positions or moving on to more sort of mental health and wellbeing based roles within their organisations. So having this increased confidence that comes with their mental health and neuroscience literacy is good because many organisations now value health and wellbeing, and so having employees with this knowledge is really preparing them for the future in terms of skills within their workforce. Finally, of course, this is definitely a pathway to high degree by research and emerging research areas. And we do have some other options available for those who are wanting to go straight into PhD or straight into a master's by research. So again, if you have those kind of individual questions, please do get in touch. Okay, so I'm going to go through Now, what our sort of content looks like. Next slide, please, then. It's really not your traditional lecture tutorial type thing. So I'm going to explain it in a little bit more detail. And hopefully this will kind of pique your interest, but also the module that you receive is a bit of an example of what our multimodal format looks like. So next slide, then. So yes, we're a fully online course. And, you know, the beauty of this course is that we do have a unique combination of mental health and neuroscience, and it's the only fully online course like this in Australia. You'll probably find a lot of mental health courses, a few neuroscience courses, but in terms of being able to offer all this content fully online, currently we do have that unique position. So that's very exciting for us. So we do sit within UniSC's usual semester dates, meaning that we offer 13 weeks of content. But being fully online, the courses are self-paced in that you can choose when you do your study. So the only deadlines that we have are assessment items, which you have to stick to those, unfortunately, but essentially you can pick when you choose to do your study and how. So for those people that might want a bit more structure, you do hear from me, your course coordinator, regularly, and you can choose to follow along in those modules week by week if you like. In terms of hours on study per week, the university kind of generally recommends 10 to 12 hours a week. A course is a rough guide. Now, this entails roughly 3 to 4 hours of taught content. And so for us, that includes modules and readings. And then the rest is self-study and then working on assessments. So with our online courses, you can obviously structure this in a way that suits your work and life commitments. You're not tied to a lecture time. You can fit it in whenever it's comfortable for you. They're designed, our modules are designed to take a couple of hours to complete, and longer if you want to engage in some of the other optional activities that we do offer, which are designed to help consolidate your learning and to help you start preparing for assessment. So obviously any additional time on top of sort of 2 to 3 hours of content is dedicated to self-study and assessment work. Now, in terms of assessments, I gave a little hint to it before, but our assessments are really focused on interpretation of the most recent evidence base for a specific topic, and then things like critical evaluation and synthesis of this type of content. So we really do encourage the skills of science communication through our assessments with various different styles of writing and presenting, rather than just testing your knowledge through exams or standard essay writing. So we are trying to send our graduates out with the skills to actually be able to communicate and apply your knowledge in a variety of settings rather than just remembering that content. In terms of timing, most of our students do work part-time or full-time. So many have actually chosen to study part-time, so 1 or 2 courses per semester. And the feedback so far tends to be that this is a better way to pace the learning, and it allows our students to focus on the content in more depth and provides opportunity to be applying their knowledge daily in their current practice, which is really exciting to see. And that ultimately encourages that lifelong learning. But we do also have students who very competently manage the full-time load. So it's really up to you to think about how much time you think you can allocate to study over the period of a semester. As we said in the video, the content is developed by a huge range of researchers, clinicians, and educators who are at the forefront of the areas. So you don't just hear from the same lecturer for every topic. This wide variety of contributors enables us to deliver most current and evidence-based content and gives us an opportunity to provide that unique blend of applied mental health and neuroscience content coming directly from the experts who are actually working and researching in the space right now. So these courses are not mental health with a little sprinkling of neuroscience. They are very much a balanced blend. So as you will hear from Dan later in the masterclass, understanding the brain is really crucial to helping us better understand mental health in general and how we can, maximize diagnosis and treatment of mental disorders. So this really does make our program different to other mental health programs that you may have seen on available. Next slide, Dan. So as I said, it's also delivered in a really unique way. We don't have your traditional 2 hours of recorded lecture format. Yes, there are 13 weeks of teaching, but each week contains what we call a module of content, which is broken up into different styles of learning materials. And this enables us to cater for many different learning styles. So in terms of how it's actually delivered, we have an amazing multimodal design rather than the traditional recorded lecture and tutorial setup. So what you'll typically find in a module of content is this. So Firstly, we have some readings, which will set the scene for the module. And these are not textbook. These are mostly peer-reviewed journal articles, so recent research. Then we go through the core concepts, which is what you would usually cover in a 1 to 2 hour lecture. And this is delivered in this multimodal format. So this means it includes a mix of text, images, graphs, pre-recorded mini lectures, other really useful videos to help explain concepts such as 2-minute neuroscience videos, which is a great resource. We also provide links to other resources like conversation articles, and then we have interactive activities so that you're able to self-check your understanding of the content as you move through the module. So we then have another set of interactive activities outside that sort of core concepts part, which the aim for those is to help you consolidate your learning, but also build towards your assessment items. So this section makes up the type of things that I guess you would typically do in an in-class tutorial or workshop type setting. So these activities are all completely self-paced, and you can choose how much you interact with your peers and your course coordinator online. So we have things like discussion boards, we have comments via videos. We also have regular Zoom drop-in sessions where you get the opportunity to meet your peers, collaborate and discuss the concepts and ask questions about assessments. But you can choose to engage in as much of that as you want. So whilst they are fully online, you do hear from me regularly, and you have multiple opportunities to connect with me and your peers and discuss the content. But at the same time, if you're a more autonomous learner, there's absolutely no obligation to engage in any of the interactive or Zoom-based activities, as the content we provide ensures that all learners are given the opportunity to access all the information necessary to succeed in the course, even if you don't want to do that stuff. Okay. I know there's a lot of information to take in, but now what I'm going to do is just give you a little bit of an idea of some of the topics that we actually cover in our courses. So this picture here is kind of a collage of some of the, I guess, landing pages that we have in our modules, just to kind of illustrate the variety of content that we actually cover. So if you do end up enrolling in the courses, you probably will see these images again. I'm just going to talk through the different courses that we have now. So we'll start off with the graduate certificate. So this is the 4 courses. So first of all, we have mental health and neuroscience translational research. This is kind of the foundational course, I guess, because we know across the lifespan that mental disorders differ in their onset type and complexity. And current diagnostic approaches and treatments remain limited and in some aspects quite lacking. So what we do in this course is we'll focus on translational research and how we can use that to better understand mental disorders and optimal treatments, and how the latest scientific research findings are actually then put into practice. That's this translational component. So we'll explore recent and novel approaches to diagnosis, such as staging models, and we also look at novel treatments, so things like transcranial magnetic stimulation, ketamine, which is a hot topic, and EEG neurofeedback. So in our youth mental health and neurobiology course, it's a great course. So the reason why we have a whole course dedicated to youth mental health is because we know that adolescence is a very dynamic period, which involves significant physical changes, cognitive and social development, and emotional maturation. It can also be a really difficult period because the brain is undergoing significant structural and functional changes. We also know that half of mental health conditions actually emerge by the age of 14. So there's a massive need for understanding adolescent neurobiology. And you'll hear a lot more about that later from Dan. So in this course, we do investigate neurobiology of disorders that emerge in adolescence particularly, and we focus on specialised youth mental health services, as well as key factors that play a massive part in the mental health of adolescents. So things like social connectedness, digital life and cyberbullying, and sleep-wake patterns. So you'll hear some of the fundamental information about adolescent neurobiology from Dan soon, and he will explain how this dynamic period of brain changing can affect the onset of mental disorders. So next we have neuroimaging advances in mental health. So this is probably the most technical course, but you know, our students are not expected to learn all the intricacies of all the different types of brain imaging. We do look at magnetic resonance imaging, or MRI, because this allows researchers to understand how the brain is wired, particularly in our context when looking at health and disease. So this course will introduce you to the latest imaging technologies that are applied in mental health and neuroscience research and treatment, but we do have a bit of a focus on MRI. In saying that, we will also explore, again, transcranial magnetic stimulation, magnetic resonance spectroscopy, and EEG techniques, and actually how those types of things are also being used in AI and machine learning. So you'll really get to understand the role of neuroimaging and neuroimaging biomarkers in mental health for things like risk profiling, diagnosis, and treatment, and also how neuroimaging supports the pursuit of new knowledge, particularly in the mental health context. That's a really cool course. They're all cool. Finally, in the grad cert, we've got understanding and preventing suicide. So we know suicidality is a significant, complex public health problem. And actually for people aged 15 to 44, suicide is the leading cause of death, and its impacts on communities are far-reaching. So in this course, we do actually look at some of the theories of suicide, as well as the current evidence base around its neurobiology, but and also the innovations in terms of assessment and suicide prevention. So the emphasis on this course is really that integration of things like policy, person-centered practice and care, the role of the community, particularly in suicide prevention. And we also explore approaches to preventing suicide in particular at-risk and vulnerable populations. Okay, so they're all the grad cert courses. So now we'll move on to the other four that make up the graduate diploma courses. So starting off with healthy brain aging. And this is also a really growing area of research at the moment, mainly because dementia is the major cause of disability among older people, with 10 million new cases every year worldwide. So healthy aging is accompanied by changes that impact cognition and behaviour, and we really do have a look at those in this course. In saying that, there is a spectrum of declining cognitive function. So we've got normal aging at one end, and then diseases such as mild cognitive impairments in the middle, and then dementia at the severe end. So we do look at that spectrum. In this course, we will address the neurobiological changes in these diseases, and we also have a look at how lifestyle factors can protect against dementia risk, even up to about 50%. So you'll learn how lifestyle interventions can actually prevent the onset and progression of things like cognitive decline. And we've got some exciting new research coming out of one of our studies at the moment. So you'll get to hear a little snippet of that if you do that course. Next, we've got neurocognition and mental health. So neurocognition is understanding how thinking skills such as attention, memory, decision-making, and how these things are kind of linked to the underlying brain regions, networks, and processes that might be impacted with mental health concerns. So neurocognition has been utilised to help us better understand the functional impacts of various mental illnesses, and that's including in their very early stages. So in this course, we will learn how a diverse range of cognitive functions, such as things like affective regulation, metacognition, which is thinking about thinking, and social cognition, and how these cognitive functions play key roles in current mental health research, and how these measures actually provide insights into the underlying neurobiology. Next up, we have stress-related disorders. So just in general, we know that stress of any kind promotes vulnerability to or exacerbates symptoms of most mental illnesses. And then particularly stress-related disorders can result because of an atypical response to anxiety due to physical, mental, or emotional stress. So things like post-traumatic stress disorder can develop if feelings of fear, anger, and depressed mood persist after exposure to a traumatic event. So in this course, we do have a focus on PTSD, and we'll have a look at how these atypical responses to trauma lead to particular disorders, and how these brain changes then manifest into those debilitating symptoms that we see in people with PTSD. Unfortunately, we also know that a lot of current treatments for PTSD are not effective. So we do have a really good look at that emerging evidence behind some of those novel therapies, including things like psychedelics. Everyone is excited about that at the moment too. Okay, so finally we have lifestyle factors in mental health. So nutrition, things like nutrition, physical activity, Sleep, substance use, stress management, and social networks, and also the environment are all lifestyle factors that can actually shape and impact our mental health and well-being. So lifestyle interventions are behaviours and actions that an individual can actually modify or change to improve their mental and brain health. So in this course, we really have a look at a lot of the emerging evidence base in lifestyle medicine, and particularly from a multidisciplinary perspective. We know that all of these things individually are really effective, but we also look at how, combining lots of lifestyle factors is now sort of becoming the most optimal way to use them. And so we have a look at the emerging evidence base in lifestyle medicine and explore ways that this approach can be adopted as early intervention strategies, as well as how it can then supplement other therapies for the treatment of mental health disorders. So as I said before, after this webinar, you'll get to have a little taste of one of our modules, and we do actually give you a little snippet from each of the 8 courses. So yeah, that concludes the information from me about our mental health and neuroscience courses that we offer. As I said, they are at a reduced rate right now, which we were very excited about because it makes it more accessible for everybody, which is awesome. Now I'll pass over to Professor Daniel Hermans, who's going to take us through this amazing masterclass where he's going to sort of talk you through adolescent brain development and how this can affect the onset of mental disorders. So
Thanks, Chrissy.
Thank
you, Chrissy. Thank you. Just a quick reminder to everyone, if you have some questions, please post them in the chat function. And if you see that somebody's already posted a question that you have, the same question, then you can vote on those. Okay, so in this masterclass, we're going to explore the dynamics of adolescent brain development and how this relates to the emergence of mental health conditions. This is content from our capstone course, Mental Health and Neuroscience Translational Research. And to set the scene, all the MHN modules start with a blurb like this. While behavioral disorders and autism, as well as anxiety disorders, are common in childhood, in adolescence and young adulthood, the other major psychiatric disorders emerge. And by the age of 25 years, most have already had their onset. But what is the pattern and impact of their emergence, and why is youth mental health such a complex, poorly understood phenomenon? So then we touch on a list of learning outcomes and proceed with the module content. In creating modules, we curate content from a wide variety of sources, including articles from The Conversation, as they capture key elements of a given topic very well. This 2019 piece addresses the issue of youth mental health, highlighting the need for a stronger focus on early prevention. Large epidemiological studies have found that around half of mental and substance use disorders have their onset before 14 years of age, and around 3/4 will have emerged by the age of 25 years. Mental disorders with childhood or adolescent onsets tend to be more severe, are frequently undetected early, and they accrue additional comorbidity, especially if untreated. It is estimated that adolescent onset mental illnesses have an economic cost of up to 10 times higher than adult onset illnesses. In Australia, around 20% of adolescents and around, or just over a quarter of young adults experience mental health problems at levels that are equivalent to a diagnosable disorder. An increasing number of Australians are now diagnosed with depression and anxiety, and this is especially the case in young Australians. In 2021, surveys found that around 40% of Australians aged 16 to 24 years had a mental disorder, and this was the highest in any age group. In this paper, the authors note that the increasing incidence of several classes of psychiatric illnesses in adolescence. And they suggest that the pathophysiology of these disorders probably stem from aberrations or exaggerations in the maturational changes that typically occur in adolescence. Furthermore, such anomalies act in concert with psychosocial and environmental factors to manifest as disorders. This figure depicts the ages of onset for the most common psychiatric disorder classes. Now, while impulse control and some anxiety disorders can emerge in childhood, other anxiety, substance use, mood, and psychotic disorders tend to emerge in adolescence or young adulthood. This figure provides more information about the incidence of mental disorders in youth, with the peaks denoting the age of highest risk. The authors propose a framework whereby the developmental trajectory, dynamic interactions of brain systems, and sensitive periods of brain function all contribute to the early age of onset and high incidence of these disorders in adolescence. That is, the strengths and liabilities of different developmental stages combined with phases of heightened plasticity, whereby neural systems are particularly receptive to life experiences, all contribute to the risk and resilience of mental illness in youth. Let's now take a closer look at adolescent brain development. This content is from another course titled Youth Mental Health and Neurobiology. It commences with this blurb. Adolescence is a period in life that is markedly different to childhood and adulthood in many respects. Have you ever wondered why this is so? And what does the brain have to do with this? Now, one of the learning outcomes of this module includes an analysis of normal and abnormal brain development during adolescence, which I will touch on now. In this paper, Lawrence Steinberg describes how the disjunctions between developing brain and behavioral and cognitive systems occurring during adolescence highlights how this is a critical period in terms of the organization of regulatory systems in the brain. A time that comes with both risks and opportunities. Steinberg presents a three-stage model of adolescence whereby the impact of puberty on emotional arousability and motivation occurs before frontal lobe maturation is complete. This gap may create a period of heightened vulnerability to problems in the regulation of affect and behavior, which might explain the increasing risk-taking and onset of emotional and behavioral problems in adolescence. Certain behaviors, including increases in social behavior and novelty seeking, are common among adolescents and may aid them in the successful navigation of this potentially stressful period in which they're acquiring the skills necessary for independence. Thus, despite massive biological, emotional, psychological, and social changes, for most adolescents, the transition from childhood to adulthood is relatively benign. However, for many, this can be a tumultuous period. In other words, while the adolescent brain is undergoing some major structural and functional changes in conjunction with other biological and social changes, it is seen as a window of opportunity or vulnerability. The prepubertal brain is extremely neuroplastic, but with this enhanced plasticity comes enhanced vulnerability that some argue is not fully observable until well after the time of insult, that is, during adolescence or adulthood. In their paper titled The Storm and Stress of Adolescence, Casey et al. Highlight that the developmental trajectories of subcortical and prefrontal regions must be considered together. As depicted in this figure, the authors note that the subcortical regions, which include the limbic system, key to emotional processing, develop earlier than prefrontal regions. This causes an imbalance during adolescence, whereby the differential timing of brain development exposes a disparity between brain systems critical to effective or emotional processing, relative to the prefrontal regions, which exert top-down control over emotional responses. In the past, perceptions of the adolescent brain have been quite superficial, and compared to other age groups, there was far less research of it. In my view, brain development in adolescence is the most important and the most interesting of all life stages. This is because brain changes during adolescence are highly dynamic, primarily due to two very important processes involving substantial changes in grey matter and white matter. Let's briefly look at these important types of brain tissue. This image from a magnetic resonance scan shows how the grey matter is predominantly located around the outer layers of the folded cerebral cortex, whereas the white matter tends to be deeper and quite distributed throughout the brain. Grey matter is a major component of the central nervous system, consisting of neurons or nerve cells and glial cells made up of astrocytes and oligodendrocytes, which provide structural support. Whereas white matter refers to areas of the CNS that are mainly made up of myelinated axons, also known as white matter tracts. Here is a depiction of a typical neuron. These nerve cells are the building blocks of the central nervous system, forming the networks that facilitate brain communication processes. Neurons have a cell body, tree-like structures called dendrites, and long axons that end in terminal boutons to send signals to other cells. The axons of neurons are wrapped in protective insulation called myelin to make the communication between cells faster. Myelin is the white matter, and it plays a very important role in signal conduction of neurons. That is, myelin enhances the electrical signal or action potential traveling along the axon of a neuron at rates significantly higher than those achieved by unmyelinated axons. This difference is estimated to be as high as 150 meters per second versus 10 meters per second. We can see here that thanks to diffusion tensor imaging, how white matter tracts are distributed throughout the brain. These bundles of myelinated axons depict the brain's structural connectivity or information superhighways. And while the total volume of the cerebrum peaks later in the second decade of life, there are important and significant shifts in the distribution of total grey and white matter that take place in adolescence. Firstly, adolescence is marked by a pruning of neurons that are no longer utilized or needed. These images depict the maturational brain changes in the transition from childhood to late adolescence, young adulthood. The general pattern observed is an overall reduction in grey matter volume with increasing age, which follows a posterior to frontal gradient. In other words, grey matter reductions occur in the posterior regions first and the frontal regions last. This has been interpreted as a situation whereby the higher order frontal regions mature only after the functions of lower order somatosensory and visual regions are integrated. Furthermore, the sequence of maturation is associated with milestones in cognitive and functional development. The authors speculated that these overall grey matter reductions may be driven by a pruning of synapses. So just to clarify, synapses are the junctions between neurons, the fixed points where one cell's axons exchange signals with another cell. Synapses are key to the way neurons can have multiple connections and therefore form complex networks. In 1979, Peter Huntenlocker conducted seminal work in the terms of the way that we understand synaptic formation and pruning. He painstakingly counted synapses in 21 postmortem brains from people ranging newborn to 90 years of age. The figure here shows the synaptic density calculated by Huntenlocker in the middle frontal gyrus according to age. The curvilinear trend here suggests two major aspects. Excuse me one second. First, synapse formation. Oh, I've lost my voice, just a second.
I'll just jump in to say we've got some excellent questions coming up and we will try and answer all those questions at the end. So thank you so much. Keep them coming. We are logging them and we will get to them. So thank you.
Thank you, Chrissy. I've been talking too much. Okay, where was I? So first, there's synapse formation, and that's the increasing density of synapses occurring during childhood. And that's around 0 to 5 years. And this is followed by a subsequent regression known as pruning of around 30% of neurons. And this is mostly in the adolescent period. This work has provided key insights into the underlying mechanisms of grey matter changes in the developing brain. And this pattern of synaptic pruning certainly seems to underpin the trajectory of grey matter volumes more recently observed in studies of humans across the lifespan. This longitudinal study of children, adolescents aged 4 to 21 years shows a more fine-grained window of the developmental trajectories in grey matter volumes. The inverted U-shaped changes across cortical regions was described as pre-adolescent increase followed by post-adolescent decrease. And while males had 10% more cortical volume, the shapes of the curves for females and males do not differ, aside from the timing of the peaks of grey matter volumes, which differ by around 1 year, corresponding to the respective onsets of puberty. The authors state that the grey matter peaks are purely quantitative and do not necessarily reflect neural efficiency. It is better to view this developmental curve as reflecting a surge of connectional growth in childhood, followed by a pruning of inefficient connections to achieve maximal function in adolescence. So when considering developmental changes in the brain, it is important to look at both grey matter and white matter. Increasingly, there is accumulating evidence of the grey and white matter trajectories in the adolescent period, with a general pattern of grey matter decreases and white matter increases across brain regions. This longitudinal study shows the same overall pattern, but with more detail, particularly demonstrating that the largest decreases in grey matter occur around 11 to 19 years of age, while the largest increases in white matter occur around 8 to 19 years of age. It's important to note that the white matter increases are offset by grey matter decreases, leading to no overall significant change in total brain volume across age groups. Thus, adolescent brain development is characterized by grey matter pruning in conjunction with increased myelination of white matter tracts, which overall enhances the neural connections that are most utilized and needed, making the brain faster and far more efficient. Essentially, the adolescent brain becomes highly specialized and unique. And as UK researcher Sarah Jane Blakemore states, adolescence is the time when we are inventing ourselves. Now, this complex figure of brain development brings together all of the above-mentioned grey and white matter changes in youth. So first, there is a refinement of prefrontal brain circuits driven by the pruning of excitatory synapses from 5 years of age, then a proliferation of inhibitory synapses, which ramps up from around 15 years of age. Thus, changes in grey matter during adolescence are far more complex than simply volume reduction, as there is a careful calibration of excitatory inhibitory balance throughout the cortex, the yin and yang of neural processes, if you will. All the while, there is a steady increase in white matter from birth to young adulthood, with the prefrontal cortex the last region to mature. Let us now examine an example of when this typical adolescent brain development goes awry. In this paper, Thomas Insel presents a neurodevelopmental model of schizophrenia and proposes that a mapping of its pathophysiology is our next best step. This seminal model has set the scene for research that continues today. Importantly, psychosis or schizophrenia nearly always emerges in late adolescence, early adulthood, when the prefrontal cortex is still developing. However, several population-based studies indicate there are problems in development that are evident much earlier. Genetics research also suggests that early brain development is affected in those with schizophrenia. Furthermore, environmental factors, including pre- or perinatal events, are also implicated. The neurodevelopmental model proposes that first, there is an early insult, then a latent period, and finally the emergence of psychosis in late adolescence, early adulthood. So Insel elaborates on this model by explaining the potential neurobiological underpinnings of schizophrenia, whereby developmental brain changes impact key regulatory processes such as the fine-tuning of excitatory and inhibitory synapses. As depicted in this figure, in the developmental trajectory of a young person developing schizophrenia, there may be excessive pruning of excitatory neurons and/or reduced elaboration of inhibitory interneurons, leading to overall alterations in the excitatory inhibitory balance in the prefrontal cortex. Furthermore, this may have only subtle effects until late adolescence, when a precise balance is required. Finally, reduced myelination further contributes to altered connectivity. Many aspects of this model have already been supported by recent research, although the ability to predict these developmental pathways and the likelihood of an individual developing a psychotic disorder remains elusive. In any case, this neurodevelopmental perspective of schizophrenia implies the importance of timing and very much drives the continued research effort to better identify any opportunities for early intervention and even prevention. The role of synaptic pruning during development continues to be a key topic in research. Importantly, as research is becoming increasingly transdiagnostic, that is, studies examining the same measures across multiple diagnoses, there may be new discoveries around how synaptic pruning triggers different mental disorders, particularly when comparing, for example, schizophrenia, which is thought to involve excessive pruning, and autism, which has been linked to an overabundance of synaptic connections. Interestingly, in both conditions, recent studies have implicated the same molecular signals being active during neural development, including the involvement of microglia, the brain's immune cells. Finally, current research is also focusing on connectomics, which is a way of exploring how different neurons and neural networks throughout the brain are connected and interact with each other to produce different types of behavior and cognition. So by way of summary, I hope that this masterclass has highlighted the following key points. Firstly, the adolescent brain is, in terms of development, is extremely dynamic. And as a result, the adolescent brain is becoming highly specialized and unique. We know that cognitive and emotional development depends on brain developmental changes. However, experience-dependent changes or neuroplasticity in adolescence can be a double-edged sword. In other words, mental health problems and mental disorders likely stem from aberrations or exaggerations in maturation or brain changes. The challenge is conducting the best, especially longitudinal, research to unravel this, and then to utilize the findings to help reduce the rising mental health problems seen in young people today. Want to know more? Well, I'm afraid we're run out of time. However, I want to briefly touch on some of the other directions that the MHN courses would take you. So for example, we explore the impact of lifestyle factors on mental health, including sleep and social connectedness. Sleep-wake disturbances are common in a range of mental disorders. We also know that sufficient sleep is required for healthy myelination to occur. Our program includes an entire module about the glymphatic system, which operates when we're asleep and serves to clean up all the metabolic waste that accumulates in the brain when we're awake. Without enough sleep, built-up waste can negatively impact the progenitor cells that are crucial for myelination, leading to impairments in brain function. Hence, addressing sleep disturbances may be a potential treatment target for many emerging mental disorders. We also look at research that shows in adolescence, changes in social environment and brain function shape each other as individuals develop. There is evidence that mental disorders can impact social networks. However, research also suggests that social networks can be protective for the onset of disorders. In some cases, social network size has been linked to brain structure and function, but further research is required to determine the direction of causation. We also refer to very recent evidence from our very own Chrissy Driver, showing that the level of social connectedness is associated with the integrity of white matter tracks in adolescence, suggesting a link between the impacts of social competence and structural connectivity in the adolescent brain. This highlights a potential protective role for social connectedness in mitigating perturbed white matter changes. I could go on, but I should stop there. So hopefully this masterclass has demonstrated to you how our postgraduate program very much incorporates neuroscience to best understand mental health conditions. And in doing so, helps us all to find new solutions for their prevention and treatment. Thank you for your time. And now it's time for questions. And I need a glass of water.
Yeah. Okay. So Dan, we do have a bunch of questions. So I'll start going through them and I'll sort of divide them up between you and I. And hopefully we'll get to as many as we can. So please do stick around if you do have time. I know it is 7 o'clock already, but we'll try and get through them all. Okay, so I have a question about assessment, so the assessment format. So I'll quickly answer that one, Dan. So each of the courses has 3 assessment items. So normally there's one around about sort of week 5 or 6, normally one around about week 10 or 11, and then one at the end of semester, normally during the exam period. We have lots of different types of assessments in terms of formats. So we have some sort of open book exams that have sort of short answer questions, fill in the gap, some multiple choice, you know, just to kind of have a look at your early understanding. Then we have things like presentations. We also have different styles of writing in terms of preparing you for manuscript writing. So we have like what's called a perspective piece, and we do some debates as well. We do position papers, so putting forward a position based on what you've read in the evidence base. So there's lots of different types in terms of the assessment formats. So I hope that answers your question. If you do want any more information in terms of the timing and what the assessments might look like, the course outlines are available on the website already. You can have a look at what we did this semester and you'll be able to see what the assessments are like next semester. Okay, Dan, this is a good one for you. So how does your teaching of the neurobiology of mental illness interact with the traditional mental illness diagnoses?
Great question. Yeah. So as Chrissy said earlier on, we do strike a balance throughout the course, throughout the program, to look at neurobiology in the context of mental illness. But we have a couple of modules, or at least one, help me out, Chrissy, that addresses classification systems, actually. So that's one thing that I would stress in terms of how many?
3 modules.
Yeah, it is 3. So those 3 modules, one is about the traditional classification systems, and then there's another 2 about new approaches to classification. So there's not a lot of neurobiology in those couple of modules, but that sets the scene for other content. And so well, actually one of them, it's very much neurobiological. So it's the research domain criteria, so that we're addressing traditional and new ways that people are looking at the classification systems for mental illnesses. And yeah, one of them in particular, the RDoC, which is research domain criteria coming out of the NIMH, the National Institute of Mental Health in the US, is very much about the neurobiology and kind of a bottom-up approach. The idea being we should look at brain systems, cells, you know, all these different layers of biology across disorders and sample across services and clinics. So we discussed that at length about the intersection between where new classification systems are going and always rely and refer back to the traditional classification.
Yeah, excellent. Thank you. Okay, it's another good one for you, Dan. So I'm curious about neuroplasticity throughout the lifespan. Is this explored in the courses? And if so, how deeply is it explored, please?
Well, I'd like to think I covered it somewhat well then. We do touch on it throughout the courses. Yeah, it's very important. It is relevant in HBA as well, healthy brain aging, ideas around plasticity, especially the hippocampus, that learning and memory sensor of the brain. So yeah, and also what happens in terms of chronic stress. So not specifically about stress-related disorders, but we see a lot of disorders, mental illnesses, as being impacted by chronic stress on the brain. So the concept of plasticity or the opposite, neurodegeneration and synaptic loss is covered quite often in multiple topics.
Yeah. Awesome. So there's a question here, do we look at complex PTSD? So we do cover that in our stress-related disorder course. And it's also one of those things that if you have a particular interest in complex PTSD specifically, you can then choose to focus on that particular disorder for your assignment. So there's definitely an element of choice in terms of, we like to call it choose your own adventure. You can choose the topics for quite a lot of your assessments. So yeah, if you do have a particular interest, you can unpack that a little bit more based around the assessment criteria. So if we were looking at treatment options, novel treatment options for complex PTSD, yes, you can have that as your focus. So we have some students that are kind of planning their assessments around becoming specialized in a particular disorder. So they might try and, choose a disorder that they have a particular interest in and try and apply that to several different assessments to get really good coverage of that particular disorder. On the other hand, you can have a look at it from a particular treatment or a particular imaging modality that you're interested in and apply that to certain assessments as well. So there's definitely an element of choice in terms of the disorders that you might want to focus on. So something like complex PTSD, you definitely have an introduction to it, and you're able to then take that investigation further yourself in your assignments. Next question is autism and ADHD. Absolutely, yes, we cover both of those. ADHD, we cover that quite a lot in the youth mental health course, but we do also have a look at autism and ADHD in our translational research course, because we talk about the types of disorders that obviously are commonly diagnosed in childhood and early adolescence. And again, if that's a topic that you're wanting to become specialised in, then as I said, you can apply those types of things within your assessments where possible. Is spirituality incorporated into any of the modules? I guess the answer is not directly, but we do cover things like mindfulness and how mindfulness and practices like yoga can actually change the brain as well, and are being used for treating different mental disorders. So again, it's probably one of those aspects that you could draw into it from an assignment perspective if you wanted to. Another question, do the programs discuss TCI, which is therapeutic crisis intervention for children with backgrounds of trauma and domestic violence? Now, we have, the topic of childhood trauma definitely plays a massive part in our stress-related disorders course. So based on that, although we don't specifically cover that therapeutic crisis intervention as a treatment, it is something that, again, if we have an assessment where you have to talk about combining different novel therapies for a stress-related disorder, so you could choose to focus on childhood trauma and the combination of something like that therapeutic crisis intervention and another novel therapy. So there's that opportunity to bring that in there, but we don't specifically cover it at this point. Probably something for us to have a look at and see if we can include something like that in our courses as well, because we are always updating the courses based on current research and interventions. So great question. Let's have a look. I think I will pass one on to you, Dan. So do the imaging studies support this theory of delay in development between brain regions in adolescence?
Yes, I guess. Well, I suppose I should say that what I was saying was a broad overview, a general idea of what's happening. There are different rates of development in different brain regions, and I would direct this the person who's asking this question to papers by there's a new paper recently led by a person called Bethlehem, very recent paper showing actually developmental brain changes across the lifespan. There's other papers I could put into if we could respond more specifically, but yeah, I'm sort of skirting around the issue. There are a lot of studies now coming out which are showing subtle differences in the trajectory of brain development across different regions. I was being a bit simplistic saying that talking about the overall pattern, but there are differences, for example, in the temporal regions and so on. I can see another question related to that one too. If I can so that one, the related question is, will neuroimaging be more frequently used in diagnosis in the coming years? Now that question excites me a lot because that's exactly what we're looking at the Thompson Institute. So in the via the longitudinal adolescent brain study, we are looking at ways where we can use brain imaging markers that predict mental health outcomes. And we have discovered one indicator already in the functional connectome. And we found that a particular network and the level of uniqueness of that network, as we've called it, predicts psychological distress 4 months later. So to get to the heart of the question, what we've done as a follow-up is we did a webinar last year, and we've published a paper in the journal called Futures about how far in the future are we from a time where we have young people getting access to scans more frequently to predict and detect mental health outcomes. So that's where there's a lot of focus on that sort of work now, particularly off the back of longitudinal studies, because the longitudinal studies are the only way that we can look at what comes first, the brain changes or the mental health changes. But at this point, I would say that the brain changes are looking very promising in predicting mental health outcomes. So I'd like to think there will be a time when neuroimaging is far more frequently used in diagnosis.
Thanks, Dan. So we have a quick question. Do we have access to fMRI? So yes, we do at the TI. We have a wonderful scanner. And in terms of the courses, we talk about the different imaging modalities. So we introduce you to structural MRI, functional MRI, diffusion tensor imaging, and magnetic resonance spectroscopy. So we do cover all of those modalities, and we do have all of those available here at the TI. You know, functional fMRI does feature a lot in the research that we talk about as well. So it's definitely something that you'll hear a lot about throughout our courses. Okay, Dan, I think this is relating to your talk. So they're very heavily based on physical aspects. Emotional and subconscious mind are extremely important too. Would you like to comment on that?
Yeah, well, I absolutely agree for a start. We haven't got this topic covered yet, but I'd like to bring it into the program at some point. And my colleague in Sydney, Max Bennett, Professor Max Bennett, is a strong proponent of the dualism that is the mind and brain. And there's some really interesting content around that about, you know, consciousness, subconsciousness, and the physical substrate that is the brain. We would very much like to bring that in, and also issues around neuroethics as well. Yes, we do focus on the biology, but I think we always try to relate back to especially emotional processing quite often, or behavior, symptoms. And yeah, of course, as Chrissy said before, I'd like to think that we're addressing the subconscious mind in some way when we cover research and work in the area of mindfulness. So some really interesting developments there about how perhaps tapping into different levels of consciousness. I'm not sure whether you could say it's subconscious, but tapping into that or altering your consciousness does seem to have tangible brain effects as well. So yeah, we try to cover it. I'd like to do more on the philosophy that is the mind and brain, but I encourage that person to look into the work by Professor Max Bennett on that front.
So Dan, I'll look at you. Is there any evidence that the development of depression might be related to this imbalance in pruning?
Well, I guess so. I mean, in terms of, I could tackle that question in two ways. I think that depression or depressive symptoms, depressive characteristics are common across multiple disorders. So if there's excessive pruning or pruning imbalance, I would expect that depressive symptoms emerge. I mean, in schizophrenia, yes, there are positive symptoms, which are things that are added to behavior, I guess, like delusions and paranoia, but there are also negative symptoms and depressive symptoms. But then the other question around that is simply ideas around synaptic loss. And so we know that chronic stress on the brain in people with depression does impact synapses and leads to, changes in neuroplasticity and even, synaptic loss. So that, that's looking at pruning in another way. I mean, pruning is an expression used in developmental literature because it's typically a natural process, but excessive pruning can be a problem, or a lack of pruning can be a problem as well.
Awesome. Okay. So there's a question here about fecal alcohol spectrum disorder. Is this covered in much detail? And could it be a condition focused on an individual assessment work? So we do briefly touch on it in one of the modules that we have in translational research when we look at the types of things that we see in childhood. We haven't had anyone focus on it yet as an assessment, but this is one of those things that I'm happy to, talk to students about, their reasoning for doing that and how they can kind of make it work with the assessment criteria. So it's definitely something we could have a chat about if that's an area that you're interested in, and how we can kind of, use the assessments to give you that knowledge in that space. So I hope that answers that question. Dan, it's definitely one for you. Are there any new methods of treating schizophrenia other than the traditional medicine, which has such bad side effects?
Gosh, I haven't heard much on that front, sadly. I know that there are others that are probably more active in the early psychosis, ultra high risk space. So I would direct the person asking the question, to some of the work done by colleagues in Melbourne and Origin, and people in that area are looking at treating functioning issues, and getting people with early psychosis into vocational positions and improving their functioning, and others are looking at cognitive remediation and so on. But unfortunately, I don't think there's been any major progress in medications, especially to treat schizophrenia. And unfortunately, schizophrenia is one of the conditions whereby people who have it can be hospitalized and spend a lot of time in hospital beds and in other facilities. And I guess people don't quite know how chronic and impactful it can be. Yeah, I'm sorry. I'll have a look around and perhaps get back to that person if they want to leave contact details around that. But unfortunately, the antipsychotic medications, which do have a lot of side effects, as stated in the question, are still quite commonly or frequently used in people, especially who have persistent schizophrenia, persistent psychotic disorders into adulthood.
Thanks, Dan. So we're going to wrap it up soon. I've just got a couple more questions that we'll get through, and then I think we'll call it a night. But yeah, there've been some really great questions, so thank you so much. I guess on that note, Dan, there's a question about, is our course solution focused on dealing with mental health issues? And if so,
I hope so, yes.
Yeah,
I mean, solutions,
definitely.
there are multiple things. So we're trying to look at new ways and to classify mental disorders, for example. I think I'm very proud of that section where we do compare the DSM, which is the Diagnostic Statistical Manual, and the RDoc, which I mentioned before, and another approach called HiTOP. So that in some way, that's a potential solution to reframing the way we categorize mental disorders and mental health conditions. We're looking at different types of treatment like brain stimulation and ketamine, and also through longitudinal and neurobiological studies, we're trying to find new solutions in terms of early identification of risk, but especially early intervention. And we do, many of our expert researchers, as Chrissy mentioned before, are clinical researchers or active clinicians or active researchers. And they often talk about what they're doing in their own practice, in their own research. That certainly does have solution focus.
All right, so I'll quickly answer a question on therapeutic interventions in the course. Yes, we absolutely cover things like that as well. Definitely important part of treatment for a lot of different disorders. So we're not completely, ignoring traditional therapeutic interventions that are still successful. So it's also about combining those things with other novel therapies as well. Final question.
I might just jump in again as
yeah.
well. I was just thinking back to another really important area in early psychosis is interventions around physical activity. So one of the expert researchers in the program, Joe Firth from Manchester, who did spend some time in Australia, he's done some great work, and the people he works with are looking at physical activity as an intervention. And again, this is more from an early intervention approach, but they're really trying to come up with new ways to address quite complex conditions like early and emerging psychosis and early psychotic disorders.
Okay, final question, and I really like this one. Do we touch on gut health and microbiome and its impact on the brain? Yes, we do have a couple of modules throughout the course where we talk about diet and mental health, and so therefore that link between the gut-brain axis. So we definitely cover that when we're looking at how nutrition can be implemented as a lifestyle factor and how good nutrition actually affects the brain. So we definitely cover that. Watch this space in terms of research too. We do have an amazing PhD student at the TI who's looking into gut microbiome, particularly in the context of anorexia nervosa. So yes, definitely an up and coming area, very hot topic. And again, one of those things that potentially you could focus on one of your assessments if that's where your interest lies. Awesome. Okay, I think we've covered all of them. There have been some really great questions, and thank you everybody for hanging around to listen to the questions as well. If I think there is a form that you can fill out if you have any specific individual questions in terms of eligibility and things like that. And as I said, you will get a copy of this recording and your little mini module, I think tonight or tomorrow, I can't remember. So that's it from me. Dan, do you want to say a final hurrah?
Just to say, firstly, apologies for my voice failing, but thank you to everybody who's attended. The interest in this has been overwhelming in a very good way, and we're very happy to follow up with any questions and other inquiries. So thanks to everyone involved, and thank you for your interest. And that's all from me. Just enjoy the rest of your day and have a great night.
Thank you.